Hello everyone and welcome back to yet another lesson, and today we are going to be talking all about capacitors, and you'll find out what that bit about the water balloons is all about in a few moments. A capacitor is a device that it generates no power of its own. It has nothing, it has no other form of energy to fuel it that would then make electrical energy. What it does is it takes electrical energy from other sources, holds onto it until it's full, at which point it accepts no more electrical energy. If you then make a circuit, it releases all of it at one time. So this is very similar to a water balloon, where the water balloon, you can actually just burst it, which you can also do with a capacitor if you can burn it out, if you try to stuff it too full. But also, it's very similar in the fact that once you burst it, it bursts everywhere. So the way a capacitor functions, it has two plates. It has the positive plate and it has the negative plate. And the positive plate is grounded either to the ground or it's in your hand, which is connected to the ground through you. And the negative plate is connected to a source of static. Now that can be a Van de Graaff generator, or like we practiced in YBH, and hopefully you guys will get to do that one day, whenever this is all over. We're going to show you other ways you can get static electricity into your capacitor. We're going to do that a little bit later. But as it's filling up, the positive side gets more positive, the negative side gets more negative. Because as the negative comes, it pushes the positive, it's trying to reach the positive is trying to reach the negative, and this gets more positive, this gets more negative. As more energy gets added, as more static gets added, more negative energy gets added, and it tries to push together, but it can't. Very sad. Why can't it? Because there's something dividing. Now that divider can be made out of plastic, glass, it can be made out of vacuum. You can just have nothing at all. Certain ones that use air as an insulator. We talked about all kinds of insulators before. So insulator is simply something that's not very good at conducting. Now, if you were to have, say, water in between it, that wouldn't function at all, because that would make a bridge between the positive and the negative, and you would just have a regular, good old circuit, which is not what we want here. We want, in a capacitor, build up electrical charge to the point where it's stuffed full, and at that point, it releases all of it at one shot in a very, very high voltage burst. So that is what a capacitor is. Now, that's very, very different from, say, a battery or a generator. Now, a generator is using movement to make electrons move around a circuit. Now, brings in movement into this equation. And a capacitor has nothing of its own. It is not making anything. It's simply storing stuff. It's also very different from a battery, although it's probably the most similar to a battery of anything, simply because a battery also has that difference in potential and has that positive side, has the negative side it wants to get back. However, the way a battery gets that is by having a chemical. We learned all about the electrolytes inside it that's splitting into its ions, and the positive ions go one way, the negative ions go one way. We talked all about this in previous times. But again, a capacitor has no power of its own, and therefore is very dissimilar to a battery. The main practical difference between these two is that this splitting up of the electrolyte into its ions takes place very slowly in comparison to a capacitor. So for instance, if you want a very large voltage surge of power at one time, you can't really use battery in any efficient way. You can use a ton of batteries and then you would get that amount of voltage, but if you want a lot of voltage from a smaller package, you need a capacitor. So now let's go talk about a little bit of the history of the capacitor, the original one who made this discovery and who developed this technology. It's a lot of fun. It involves very fuzzy dogs. Let's go. All right, so now let's talk about the history of the capacitor. Originally, it was not called a capacitor, it was called a condenser. In fact, in many countries, it's still called a condenser. The US is called a capacitor, with the exception of something called a condenser microphone. Here's a photo of a condenser microphone. And they all use the same technology. Simply, you have a positive plate, which causes the negative plate to become much more densely packed full of electrons. Hence the term condenser makes it more dense of electrons, or capacitor, because it increases the capacity. The positive side increases the capacity of the negative side to hold electrons. Without the positive side, there wouldn't really be many electrons. So let me take you back to the 1740s in northern Poland, which in those days was an area known as Pomerania. You're never known as the dog breed of the Pomeranian? Well, that's where that comes from. This is by far my favorite character so far, simply because he was one of the earliest that we talked about, and also he comes from the place where Pomeranians come from, which is hilarious. Deacon in the Church of Kamin in Pomerania, who was named Ewald George von Kleist. And so back in the day, there was very common to have religious figures who were also scientists and physicists and all those things, and he was. And he was operating under the idea, which at the time was accepted by everybody, that electricity was a fluid. And they had come up with the Van de Graaff generator, basically, and they had made static electricity. They had a friction machine that you can make static. And one of his friends, a guy named Matthias Bose, headphones? Maybe. He didn't invent headphones. Matthias Bose had come up with what he called a prime conductor, which is a piece of metal that conducts electricity. And that was a, whoa, big deal at the time. So what Ewald George von Kleist did, that's fun to say, what he did is he took his friction machine that made static electricity, attached it to this conductor from his friend, and hooked it up and attached the conductor to a bottle, a glass bottle, with a spike through it full of alcohol. Now, as you know, it has a little seal on the top to make sure that it didn't escape. So as I'm sure you know, if you mix electricity and alcohol, you're going to end up with an explosion. If you're ever giving anyone CPR, and you have the defibrillator pads, they tell you in lifeguard school, do not rub down the patient's chest with alcohol, because you know what's going to happen? When you zap them, you're going to set them on fire, which probably isn't the worst of their concerns at that point. But still, if you mix alcohol and fire and electricity, you end up with fire, which is exactly what happened. The static electricity did transfer through his machine and through this thing and into the bottle, and it caught fire. And so he repeated this a couple of times, but this time he did it with water. When he did it with water, so he had the thing in his hand, the bottle in his hand, had the glass bottle in his hand, and he turned on his friction machine. He cranked it up. He had his assistant probably crank it up, and the static went and it traveled and it went into the bottle. And so he was detaching his bottle and he touched it and he got a massive shock. And he was very, very surprised. He did, is he sent his findings to all of his friends. And one of the places he sent this off to was Pieter von Mussenbach, or excuse me if I can't pronounce it, it was somewhere in Leiden. So he sent off to, who was the physics professor in Leiden University. And what they did is, so the students at Leiden University, the graduate students, they went as grad students do, and did a lot of experiments on behalf of these people, and they came up with the following idea. If you have a metal spike into the water, it's a glass thing, it's an insulator, and on the other side is a positive charge because you're holding it and it's connected to the ground, then it can store a vast amount of electricity. So now, we did talk about this before because, if you remember, we talked about Ben Franklin with his kite into the sky, channeling the power of the storm, the static from the storm, into a Leyden jar. We got his little jam jar full of battery stuff. Or into a bunch of them, actually, and thereby storing the electricity, which he then felt with his finger, and whoa, there was a powerful shock. Now, Ben Franklin, there was actually something interesting here I want to share with you, and that is until now, we didn't have a term. They had the term the Leyden jar, named after Leiden University, but they didn't have a term for the voltaic pile. The voltaic cell was just a voltaic cell. They didn't call it a battery. If those of you who have been to museums or military museums, you see there's a whole bunch of cannons set together. It's called a battery of cannons. And what Franklin did is he took a whole bunch of Leyden jars and arranged them in series so they could hold more electricity. And so when he actually did his lightning experiment, he would not have one Leyden jar with him. He had a whole bunch that were all wired together. And he referred to this as a battery of jars, a battery of Leyden jars. And the name stuck. And since then, we've changed the meaning to instead meaning a bunch of capacitors. We now mean it to be a bunch of electrovoltaic cells, or in more familiar terms, a battery that we have today. But that is the origin of the word battery. That is the origin of the Leyden jar by L. George von Kleist in Pomerania. And so now we know where it comes from. We know what it is, we know how it works, and now, dear children, it is time to build it. So let's head into my little workshop or dining room table, and let's build our very own Leyden jar. So we're gonna let you know what you need and how to do it, and let's go. Hello everyone, and welcome back to my dining room table. Today we are going to build a Leyden jar. So, you will need, for this project, you'll need a water bottle, or really any plastic container with a lid. Here's the lid for my water bottle. You'll need a screw or a nail if you're using a screw. Need a screwdriver. If you need to have a nail, get a hammer. We'll show you how to use that. You'll need a little bit of salt. You'll need a rubber balloon, or a balloon of any kind, and you'll need some tin foil. So before we begin, I just want to let you know a couple of things. First of all, what we're about to build, a Leyden jar, has the capacity, not particularly this one, but the concept has the capacity to hold enough charge to be dangerous to a person. So there's a reason why I selected this size water bottle, because this cannot hold enough charge to be dangerous to a person. But if you were, say, to go, and I saw when I was doing research, there was someone who on the internet who made a gigantic one out of a like a 5-gallon bucket. If you do that, that one has the capacity to hold enough charge to hurt somebody. So let's keep this small. That said, this size, you will not hurt anybody. You could get a small shock from it, but that's not going to hurt you. So if you don't want that, then don't touch it. If you do want it, then go for it. It will not hurt. Okay, so to make this, we start off with our water bottle. It can be a sealed water bottle. You don't even have to actually open the top. You can leave this sealed the entire time. So we have our plastic bottle, we have our screw. And in my case, I used a screw, and the first time I did this, I screwed it in with a screwdriver. Now I can just do it with my finger since there's already a hole in it. So we're just gonna attach that in there. And it is important to make sure that the metal of this thing is touching the water. If it's not touching the water, it's not gonna go. So we'll just attach that in there. Okay. Alrighty. Okay, so now we have the metal touching the water. Good. Next up, you need to coat the outside with tin foil. So ideally, you want it to be a flush coating. You don't want it to have a lot of space. You will be holding it when you charge it, but either way, you want to be pretty tight on there. So let's go take a piece, place this in the middle, and wrap it up. There is one thing: you do not want the tin foil to go all the way up to the top, because if it does go all the way up to the top, there's a chance that when you are charging up your Leyden jar with static electricity, the static is going to build up on the outside and not the inside as you want it, and it's just not going to go where you want it to go. It will charge, but it's not going to have the effect that you want. So keep that in mind. So this is good. This is about halfway. This is great. It's about you can keep on the wrapper if you want. Doesn't matter. And there you have it. So now you have your tin foil, you have your metal spike, in my case it's a screw, and that is all in your water bottle. I nearly forgot to talk about the salt. If you would like, you don't have to do this, it's not necessary necessarily, but if you would like to make your water extra conductive, you could add a little bit of salt to it. So, we're gonna unscrew that. And just a little bit of salt. Doesn't have to be a ton. There we go. Okay. Even that's probably excessive. Unnecessarily large amount of salt. So that's fine. Anyway. Okay. So now just put that little cap back on, seal that up, and there you go. All right, everyone, so at this point we have built our Leyden jar, and now we must charge it and then discharge it into your finger. And so there are a couple things you need to charge up your Leyden jar. Number one is you need a way to generate static electricity. Now, if we were in school, we could use the Van de Graaff generator, But seeing as you are not in school, and I'm not in school, and I'm in my dining room, we are going to use a balloon. If you do not have a balloon, there are other options, other ways to generate static. You could hang out near the dryer right as things are done and take things out and charge up your Leyden jar. You could also get a bit of PVC piping, which is this long, it's plastic, it's like thick plastic. They use it for plumbing sometimes. You can take it, you can take a piece of paper towel, put gloves on so your hands are insulated, and rub it, and it generates a lot of static very quickly. What we're gonna do though is we're gonna use a balloon, but this is not quite as effective as the PVC, but this is what we have on hand. Hope you have it. This is what I have. I don't have any PVC piping, so that's basically what we're doing. Okay, so we're gonna inflate this and tie it off. Perfect. That's good. Little trick to tie it off. You take 2 fingers, stretch it around it, and then you can put it through. If you're just using 1 finger, then you're gonna have a hard time getting the spare bit through it. But here, nice and smooth. All right, so there's one last issue before we start doing this, and that is with your hands. If you have your hands, if you're holding the balloon and you're rubbing it into your head, the static is not gonna stay in the balloon. The static, some of it's gonna stay in the balloon, but some of it is going to travel down your arm. And so you want to do is you want to insulate yourself from the balloon by wearing gloves. This experiment is tailored to this pandemic. There is literally no house in this country at this point that does not own several pairs of disposable gloves, or non-disposable, even better, they're even thicker. So take this and put on your gloves. There you go. Also, very important, you only want to have gloves on this hand because, in my case, I'm going to be holding the balloon with this hand. You do not want gloves on the other hand, and you'll see why in a moment. Okay, so now we're going to take this, we're going to free up some headspace, and we're going to rub it on my head to gather up some charge. All right, and very quickly, fairly quickly, also if the balloon is tight, it gathers charge better. So inflated a fair amount. This is good. You'll start feeling your head starts getting tingly, and that's because static is being built up on the balloon, and your head is becoming positively charged, it's becoming negatively charged. All right. So now that means there's charge in the balloon. So what you want to do, you want to take your free hand and hold the tinfoil as you bring the balloon close to the nail on the top. There you go. You should hear some like zzz and like some tingling going on from the nail and the balloon as it's transferring electrons from here into the Leyden jar. And then you repeat. And then we fast forward. All right, we are all charged up, and now it is time to discharge your Leyden jar. Now, before we do that, a couple things need to happen. First of all, you need to take your glove off, because otherwise it's going to stop the charge from going. The other thing is that if you want, you could actually involve the whole family, whoever is willing and able and not scared of this, to participate. You actually form a chain of people, have everyone hold hands. One holds this, and the other end of the chain touches their finger to the top. Now, when that happens, the entire row will feel a little jolt. It's called the Ring of Fire. Some people call it that. Anyway, point being is that you will feel a little jolt. Now, if you don't do this correctly, or you don't put very much static into it, it's not going to go very far. But let's see. So we're going to hold it like this, and we're going to take our finger. And ready, and okay. So, all right, everyone, we have now built our Leyden jar. We have now charged it, we have discharged it, and so that is my time for today. I hope you all have had a wonderful time. Tomorrow we will be having a quiz on the past little bits that we've done, pretty much everything since the last quiz, and that'll be Shavuot, so enjoy that. Anyway, so please send me a photo of your completed jar, please send me a photo of your notes, or submit them using Google Classroom. And please remember to submit whatever it is, your assignment, this as in that you watched the video. I think when there's a option in Google Classroom to say, submit, turned in, I did it. So just, if you have, just please let us know that you've done it, just so we have an idea of what's happening with that. Anyway, have a wonderful, wonderful day, and you will see me tomorrow.